Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 10, Section 7, Area and Circumference of Circles. And in this video, we're going to be taking a look at the area of a circle, which is pi times r squared. So the thing to be keep in mind about area of a circle is if you have the radius of a circle, then you can find its area. And let's say the radius was 3. You would want to plug in the 3 for radius. But you have to remember, order of operation dictates that exponents come before any multiplication. So the first thing you have to do when solving for area of a circle is square the radius. So 3 squared is 9. And so then you would do 9 times pi to get the area, which would be somewhere right around between 27 and 30 inches squared or feet squared or whatever unit of measurement you're using. So pi r squared is the area formula for a circle. Make sure you write that down, take notes on that. And then this is how you would use it. And of course you would want to multiply 9 times pi and finish that up. Now, another question I often get with area is, why does pi r squared get you the area of a circle? That seems a little weird. I think the explanation that has resonated most with students, or made the most sense with students, is a very simple visual proof. And there are some that will call this technically not a proof, but I think it's the best I can do for a 7th grade, to get a 7th grader to understand this. If you take the circle and you cut it into 8 equal pieces, of course I didn't put it into 8 perfectly equal pieces because I'm hand drawing it. So you can kind of look at it like a pizza. We have 8 slices of pizza here, and you could actually test this at home with a pizza if you really want. I would have brought one in, but I don't have any money right now, so deal with it. What you can do with those pizzas or slices is you can arrange them just like we took the trapezoid and we split it into 2 triangles, and we took the triangle, we cloned it, and we arranged it into a rectangle. We're going to do something similar with the circle. We're going to take those 8 pieces and we're going to arrange them into a parallelogram, because each of those pieces is very similar to a triangle. Okay. And one thing I want to point out before I finish showing you what this parallelogram would look like is the height of this figure is going to be represented by a line that goes from this point here straight up to this point here. Now, if you remember correctly, when we were cutting our circle, you take a look at these 8 pieces. I can take any line I want I can draw any line I want from the center point of this circle, go to the outside of the circle, and that line represents the radius of the circle. Radius is defined as a line, a straight line, or a straight line heading out from the center of the circle to the outside perimeter, or to the circumference of the circle, to the outside edge of the circle. If you take a look at each slice of pizza, their pointy end is the center of the circle. So this is technically where the center of the circle was. And their curved edges are the outside edge of the circle. So if I take a line, if I draw a line from its pointy end to the curved end, then technically what I am doing is I am drawing a radius of the circle. Okay? And what you're also going to notice is that the edges of the pizza, so this slice of pizza right here, for instance, each of its edges also represents the radius of a circle, of this circle, because the edges are going from the center to the outside. So I could even draw another line right here, just like I did here, right? And this also represents the radius. This represents the radius. This represents the radius. This represents the radius. So really all these lines inside the circle are the same size, they're the same length. So that's going to be an important concept to understand, that when I draw this line here, eventually here, to represent height, that line actually represents the radius of our circle. So again, I'm going to take those 8 pieces of pizza, or those 8 slices, and I am going to arrange them into a parallelogram. And of course my parallelogram is not going to be perfect because I'm hand drawing it, so my pieces are supposed to be the same size. Obviously they won't be. So I got one more piece to do. Okay. And what you're going to notice is all these circles I'm putting on are the pointy ends of my pizzas. Okay, all these little circles I'm drawing in. So each one of them represents a piece that once upon a time inside my circle was the center of my circle. Okay, so if I have my original circle cut in 8 pieces, all the pointy ends of my pieces of pizza are right here at the center of my circle. So 1, 2, 3, 4, 5, 6, 7, 8 pointy ends all converge together into the center of my circle right here. So all of these represent the center of my circle. What you're also going to notice is that I line the pizzas up in such a way that the bases, or the bottom side in this case, okay, these four edges right here, these 4 edges right here represent the outside edge of my circle. They represent the circumference of my circle. Okay. Now on the bottom there's only 4 of the 8 slices, so the bottom side only represents half of the circumference of my circle. Okay. 1, 2, 3, 4 pieces. The bottom represents half the circumference of my circle. The top side has the other half. So here's the first half of the circumference of my circle, because here's the first 4 edges. Here's the second half of my circle. So total, if I added the top and the bottom together, I would get the entire circumference of my circle. Now, the question is probably still brewing, why did I take these 8 slices of pizza, arrange them so that they look like a parallelogram? What does that have to do with area? Okay. Well, the formula for area of a parallelogram is base times height. My base of this parallelogram happens to be the half of the circumference, because there's 1, 2, 3, 4 pieces of pizza's outside edges on my base, and we talked about how that's half the circumference. So if you remember correctly, circumference was equal to 2 pi r, or 2 times pi times radius. So I have 2 pi r's, half of that would just be 1 pi r. Right? Half of 2 is 1. So in other words, my base is equivalent to pi r, because circumference, all of circumference is 2 pi r. So if I divide this by 2, I'm just left with pi r. Okay. My height of my parallelogram, like I said, you have to, in order to find the height, you have to go from the very bottom to the very top. So we're going from here to here. The height is actually the radius of my circle. Okay, so the height of my parallelogram is the radius of my circle. And in order to find height, and in order to find the area of a parallelogram, you have to do base times height. Well, my base is pi r. My height is r, or radius. So if I do base times height, or in other words pi r times r, I should get the area formula. Radius times radius is radius squared. So when I multiply pi r times r, then I will get pi r squared. So that's that kind of simple visual proof for why the area formula works, where it kind of comes from. It is definitely not an in-depth mathematical proof, but I think it's enough that it makes sense and gets the point across, especially to the 7th graders I teach. So this is the pi area formula, remember, pi r squared, and then this explanation. If you have trouble understanding why it works, you can always, again, pause the video, ask me for help. I can sit down with you and try to explain it a little bit clearer, a little bit slower, maybe use some different pictures. We can figure something out, so just let me know. All right. The next video will actually be on Chapter 10, Section 8, Composite Figures, Area of Composite Figures.